The silence is the problem, not the darkness, not the distance, not the incomprehensible scale of space that stretches beyond anything the human mind was built to hold. Those things we can accept, because we've always lived with mystery. But the silence, the total, unbroken, absolute silence, that is something else entirely. Because by every calculation we have, the silence should not exist. Our galaxy is 100,000 light years wide. It holds somewhere between 200 and 400 billion stars. Most of those stars are older than our sun, some by billions of years. We now know, with certainty, that planets are not rare. They are the default. Nearly every star hosts them, and among those planets, conservative estimates suggest tens of millions sit in zones where liquid water can exist on the surface. Zones where chemistry can happen, where complexity can grow, where, given enough time, life, perhaps even intelligence, could emerge. The universe has had 13.8 billion years to run this experiment. That is not a long time in the way a human life is long. It is a duration so vast that even a civilization that needed 1 billion years to develop, another billion to reach the stars, and then spread at just 1% the speed of light, would have had enough time, more than enough time, to reach every corner of this galaxy, every star, every system, every world, including ours. The math does not suggest the galaxy should be full of life. It demands it. And yet we listen, and we hear nothing. No signals cutting through the radio spectrum, no megastructures dimming distant stars, no probes in our solar system transmitting data back to whoever sent them. No ruins, no artifacts, no footprints of any kind left behind by anything that came before us. Just silence. That silence has a name. Physicists call it the Fermi Paradox, and the longer you sit with it, the more unsettling it becomes, because it does not feel like a gap in our knowledge. It feels like a warning. It started with a question that almost no one heard. Los Alamos, New Mexico, summer of 1950. A group of physicists walking to lunch through the dry heat of a place that had, just 5 years earlier, changed the nature of human warfare forever. The conversation was light. Someone mentioned the cartoon. Others talked about reports of flying saucers appearing in the newspapers, the kind of story that floated through popular culture and meant nothing. Then Enrico Fermi asked the question. No preamble, no dramatic pause. Just a simple, almost offhand remark dropped into the conversation like a stone into still water. "Where is everybody?" His colleagues laughed. But Fermi wasn't joking. He had been running numbers in his head during the walk, the way he always did, quietly, behind whatever expression he was wearing. Fermi had a particular gift. He could take a problem with almost no data, make a series of careful estimates, and arrive at an answer that turned out to be startlingly close to the truth. He once estimated the power of a nuclear explosion by dropping scraps of paper into the shock wave and watching how far they drifted. He didn't need instruments. He needed logic, scale, and honest mathematics. And the mathematics of the galaxy, he had realized, pointed somewhere deeply strange. If civilization can arise, and if, once arisen, it survives long enough to reach the stars, and if interstellar travel is possible even at a fraction of the speed we might one day achieve, then the galaxy should have been colonized long before humans ever walked upright. The timeline doesn't just allow for it, it almost requires it. So where's everybody? That question has never been answered. Not fully, not satisfyingly, not in a way that lets you put it down and stop thinking about it. But there are proposed solutions, and the deeper you follow them, the more disturbing the picture becomes. Begin with the most comforting possibility. Maybe we are simply early. The universe spent its first several billion years in conditions hostile to life as we understand it. Heavy elements, carbon, oxygen, iron, the materials life is built from, had to be forged inside stars and scattered across space through supernovae. Early galaxies were violent places, gamma ray bursts, constant bombardment, Radiation levels that would have torn apart any complex chemistry before it could take hold. Perhaps the conditions for stable, long-lived civilizations only became possible recently on a cosmic timescale. Perhaps we are not late arrivals to a crowded party. Perhaps we arrived before the party has begun. Pioneers, not stragglers. The first intelligence to reach a certain threshold in a galaxy that is still, in some sense, waking up. It is a comforting thought. It means the silence is not a warning. It is simply a matter of timing. But sit with it a moment longer. Even if intelligent life only became possible in the last billion years, that is still a billion years. A billion years in which a single civilization arising anywhere at all with a drive to expand would have had time to reach every corner of this galaxy many times over. Even if the probability of intelligent life emerging is extraordinarily low, the sheer number of opportunities across that span of time makes it almost impossible for us to be the very first. Almost impossible, but not impossible. And so we move on. Because if we are not simply early, the alternatives grow heavier. Maybe the silence means civilizations don't last. This is the hypothesis that tends to stop people mid-thought because it requires confronting something most of us would rather not think about directly. What if the development of intelligence is not an escape from danger, but an introduction to a new kind of danger? What if every civilization that reaches a certain level of technological capability eventually encounters a threshold, a point of no return that almost none of them survive? Scientists call this the Great Filter. The idea is elegant and terrible. Somewhere along the path from simple chemistry to spacefaring civilization there is a step, or perhaps a series of steps that functions as a wall. An obstacle so difficult, so catastrophic, that almost every species that approaches it is destroyed or collapses back into silence. The Fermi Paradox, under this framework, is not a mystery about where civilizations are. It is evidence that they don't make it. The question that matters enormously for us is where that filter sits. If it lies behind us, we can breathe. The filter might be the emergence of complex cellular life, which took nearly 3 billion years on Earth, even after the planet had stabilized, or the leap from single-celled organisms to multicellular ones, or the improbable sequence of events that produced a brain capable of abstract thought. Each of these transitions, when you examine them carefully, looks less like an inevitable progression and more like an accident. A lucky accident, repeated just enough times to produce us. If the filter is behind us, then perhaps the silence makes sense. We made it through. Almost nothing else did. But here is where the story turns. What if the filter is ahead of us? The search for extraterrestrial life has historically been framed as a hopeful endeavor. We point our instruments at the sky and we look for signs of others because we want to find them. We want the universe to be populated. We want to not be alone. But there is an argument, a deeply unsettling one, that finding life, even simple life, on another world would be among the worst news humanity has ever received. Think about it carefully. If we discover that Mars once hosted microbial life, or that the ocean beneath Europa's ice is teeming with organisms, or that some distant exoplanet shows unmistakable biosignatures in its atmosphere, that discovery would tell us something crucial. It would tell us that life is not a rare accident, that chemistry, given the right conditions, tends toward life, that biology is almost inevitable across the universe, and that changes everything. Because if life arises easily, then the Fermi Paradox deepens catastrophically. If biology is common, intelligence should be common too, eventually given enough time. And if intelligence is common, then civilizations should be everywhere. But they aren't. We see no evidence of them, which means something else must be responsible for the silence. Something that erases civilizations before they can become visible. Something that may lie directly ahead of us. The more common life turns out to be, the more likely it is that the great filter, whatever destroys civilizations, is not behind us. It is waiting. That is the terrifying geometry of the Fermi Paradox. The better the news for life in the universe, The worse the news for us. We tend to imagine existential threats as arriving from outside. An asteroid, a supernova, a hostile alien fleet appearing over our cities in the way we've always imagined contact to look. Something external, something we could, in principle, see coming and respond to. But the most credible proposed filters are internal. They are what happens when a civilization's capabilities grow faster than its wisdom. Nuclear weapons appeared within decades of humans first understanding atomic structure. The gap between discovery and catastrophic application was almost nothing. Biological tools capable of designing pathogens now exist in laboratories around the world, and the knowledge required to misuse them is narrowing. Artificial systems of increasing sophistication are being built faster than any global framework for understanding their implications. Every one of these is a capability threshold, a point at which the power to cause irreversibly civilization-ending harm becomes accessible, not just to governments, not just to well-funded organizations, but eventually to individuals, to small groups, to anyone willing to learn. This is not speculation. This is the trajectory we are already on. And if this trajectory is universal, if every civilization that reaches a certain technological level must pass through a period where it has access to instruments of its own destruction before it has the wisdom or coordination to manage them, then the Great Filter might not be a single catastrophic event. It might be a window, a narrow, dangerous window through which very few civilizations successfully pass. We are in that window now. There is one more proposed solution to the Fermi Paradox, one that doesn't require civilizations to destroy themselves, one that, in some ways, is the strangest of all. What if they're here and we simply can't perceive them? Not hiding, not evading us, just existing at a level of complexity or scale so far beyond our current comprehension that we don't recognize what we're looking at. The same way an ant colony has no framework for understanding the city it's built beneath. A civilization millions of years more advanced than ours would not necessarily communicate via radio waves the way we do. Radio waves are what a civilization uses in its early centuries. A species that has existed for 1,000,000 years might operate on scales we haven't theorized, using methods we haven't imagined, with intention shaped by context we have no reference point to understand. Or perhaps what we call the laws of physics are not fixed. Perhaps sufficiently advanced beings have learned to engineer reality in ways that look, from our vantage point, indistinguishable from nature. Perhaps the universe itself, as we observe it, is not what it appears to be. Perhaps we have been staring at the evidence all along and simply don't have the eyes to read it. This is not a comforting thought. It is, in its own ways, unsettling as extinction, because it suggests that even if we survive the window, even if we navigate past every filter behind us, we might still remain permanently invisible to whatever is truly out there. Small, unnoticed, uncomprehending. The silence has not changed. We have sent our own signals now. Voyager 1 and 2 are drifting out beyond the edge of the solar system, carrying golden records encoded with the sounds and images of human civilization. We have broadcast radio waves into space, not intentionally, mostly just the ordinary noise of a species that discovered electromagnetism. Those signals have been radiating outward for over 100 years, expanding in a sphere 200 light years wide to any civilization within range, equipped with instruments capable of detecting them. We are visible, and still nothing answers. There are about 2,000 star systems within that 200 light-year radius. We don't know if any of them host observers. We don't know if any of them are listening. We don't know if our signals are recognizable as anything more than background noise to whoever, if anyone, receives them. But the question remains, where is everybody? Fermi asked it at a lunch table in 1950, almost as a joke, and the answer has not come. 70 years of increasingly sophisticated listening have produced nothing. The universe remains silent in every frequency we know how to use, every direction we know how to look. Here is what we know. Life on Earth took almost 4 billion years to produce a species capable of asking this question. 4 billion years of extinction events, ice ages, mass die-offs, asteroid impacts, a gauntlet of catastrophes that could have ended the experiment at any point. We survived all of them. We became, as far as we can tell, the only thing in the observable universe currently looking up and wondering. Maybe that is the answer. Maybe the universe is not silent because it is empty. Maybe it is silent because producing something capable of asking the question is so improbable, so contingent on a chain of accidents so long and so fragile that it happened here, now, once, or maybe this silence is a pattern, a signature, evidence that whatever comes next, whatever threshold we approach, very few who have stood where we stand have made it through to the other side. We don't know. We don't know which it is. And perhaps that uncertainty, not the darkness, not the distance, but the not knowing is the most honest place to leave this. The math says the galaxy should be full, the sky says otherwise. And somewhere in that gap between what should be and what is, the most important question in human history is still waiting for an answer.